What if the universe just broke one of its own rules? Recently, scientists analyzing deep space observations noticed something unusual near one of the most mysterious objects in existence, a black hole. The data came from the powerful James Webb Space Telescope, the most advanced space telescope ever built. And what it revealed has sparked curiosity, debate, and a wave of new questions among astronomers. Because in the data, researchers noticed patterns. Strange, repeating signals appearing close to the edge of a black hole, not random chaos as many would expect, but something that looked almost organized. And that is where the mystery begins. To understand why this is so surprising, we first need to understand what a black hole really is. A black hole forms when a massive star collapses under its own gravity. The collapse becomes so extreme that it creates a region of space where gravity is unbelievably strong. At the center lies something called a singularity, a point where the known laws of physics begin to break down. Surrounding the singularity is the event horizon. This is the boundary where gravity becomes so powerful that nothing can escape once it crosses it. Not matter, not energy, and not even light. That is why black holes appear completely dark. For decades, scientists believed that anything passing the event horizon would simply disappear from our universe forever. From our perspective, there should be no visible structure coming from inside that boundary. But the universe often surprises us. Using its ability to observe the cosmos in infrared light, the James Webb Space Telescope can detect extremely faint signals coming from distant galaxies and energetic environments around black holes. While examining regions near supermassive black holes located in active galactic centers, astronomers began noticing unusual energy patterns. These signals appeared as repeating layers of light distortions and radiation fluctuations close to the edge of the event horizon. At first, scientists assumed this was normal behavior. Black holes are surrounded by incredibly hot disks of gas and dust called accretion disks. Material spirals inward at enormous speeds, producing powerful radiation and magnetic activity. But some of the observed patterns did not perfectly match expectations. Instead of appearing completely chaotic, parts of the data suggested something more structured, almost like rings or echoes of light trapped by gravity. One possible explanation involves something known as photon rings. When light passes extremely close to a black hole, gravity bends its path dramatically. In some cases, light can orbit the black hole multiple times before escaping. Imagine beams of light circling the edge of a cosmic whirlpool. To a telescope like Webb, these looping paths can appear as layered patterns of energy surrounding the black hole. This effect alone can create shapes that look surprisingly organized. But some scientists think there might be more happening at the boundary of black holes than we previously understood. And this is where physics enters one of its greatest mysteries. There is a long-standing puzzle in science known as the black hole information paradox. According to the rules of quantum physics, information about physical systems should never truly disappear. Yet black holes seem to destroy everything that falls into them. So the question is simple, but incredibly deep. Where does the information go? Some theoretical models suggest that the event horizon may act like a surface that stores information about everything that falls into a black hole. Instead of vanishing, the information could be encoded in extremely tiny patterns within space-time itself. In other words, the boundary of a black hole might not be empty or smooth at all. It could be incredibly complex. If this idea is correct, the strange signals and patterns detected near black holes might be revealing new details about how space-time behaves under extreme gravity, and possibly how information is preserved in the universe. There are even more speculative theories that push this idea further. Some physicists have proposed that black holes might contain deep internal structures formed by compressed space-time. Others suggest the possibility of wormholes connecting distant regions of the universe. And a few theories even explore the idea that new universes could form inside black holes. These concepts sound like science fiction, but they come from real attempts to reconcile general relativity with quantum mechanics. In truth, scientists are still trying to understand what actually happens beyond the event horizon. However, it is important to be clear about something. No telescope,